Alright, so welcome back. So we're getting ready to build up to a result known as the binomial theorem. And so the first thing we want to introduce are what are called binomial coefficients. Binomial coefficients. Remember, binomial is a two-term expression, so the binomial theorem is going to relate to a two-term expression like x plus y, and we're going to be talking about raising that to a power. Okay, so that's the idea here with the binomial theorem that we're eventually going to build up to. First, we want to introduce these things called binomial coefficients. So binomial coefficients is the result of taking p times p minus 1, and you continue down until you get to 1 more than p minus k. 1 more than p minus k. And that's all over k factorial. Another way to do this that's common, but we're choosing this version of it for several reasons, is to do p factorial over p minus k factorial times k factorial. And then the thing that we have right here is the result of taking p factorial divided by p minus k factorial. Okay, so that gets us to that point. Okay, so when you cancel out the p minus k factorial, then you're just left with p multiplied until you get down to 1 more than p minus k, and then left over k factorial. But we write it this way, continue to subtract k until we get to p minus k plus 1, and then all over k factorial. There's reasons for that. They're going to become a little clearer later on. So here we allow p to actually be a real number. So where p is a real number and k greater than or equal to 1 is an integer. Okay, and then by definition, we also define p select 0 things to always be 1. Binomial coefficients selected 0 times is 1. Okay, so by definition, that is just 1. P select 0 things is 1, since it doesn't fit quite with this formula. Okay. All right, so this is called the binomial coefficient. Maybe you've seen this before, but we're going to be using it initially here with integer values like 5, choose 3. All right, that would be 5 times 4 times 3. Remember, it's 1 more than p minus k. So 1 more than 5 minus 3. And then that's all going to be over 3 factorial. 3 factorial is 3 times 2 times 1. And you simplify this, and we would get that 5 choose 3 is 10. Okay. As another example, 7 choose 2 would be 7 times 6. So it's down to 1 more than 7 minus 2, which would be 5. Right? So 7 minus 2 would be 5, so it would be 7 times 6. So 1 more than 7 minus 2. Right? That's the formula. And then over that 2 factorial. So notice the numerator, the easy way to remember it, is the numerator is going to have as many terms as the denominator. And then we would multiply that out. 7 times 2 is 42. Divided by 2 would be 21. If you ever apply the binomial coefficient to the actual number, like if we did 4 choose 4, then right, we would have 4 factorial on the bottom, 4 times 3 times 2 times 1, and this would go down until you get 1 more than 4 minus 4, 1 more than 4 minus 4, which would be 4 times 3 times 2 times 1. That's always just going to be 1. Right. If you ever have the binomial coefficient where you're choosing that thing with itself, that's actually always going to be 1. And one other example here, a couple more examples here with binomial coefficients. 12, choose 6. And you're going to have 6 things in the bottom, so we're going to have 6 things in the top. So in the bottom we're going to have 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. And at the top we'd have 12 times 11 times 10 times 9 times 8 times 7. Right. And we would just multiply all that out at the top, all at the bottom, and simplify. Or, of course, you could go through and start canceling stuff from the top if you wanted to as well. That'll just multiply out to be 924. One thing you might be interested in is, what if I choose a bigger number than what I have? What if I choose a bigger number than what I have? Well, the rule up top doesn't care. It says just keep multiplying down till you get 1 more than the difference. So the difference between 5 and 6 would be 5 minus 6 would be negative 1. 1 more than that would be 0. So this would be 5 times 4 times 3 times 2 times 1 times 0 all over 6 factorial. And because that top includes a 0, that's going to be a 0. So if we ever have a number and we're choosing a number bigger than it, well then that's going to end up being 0. That's going to end up being 0. Okay. Now, these binomial coefficients are also built into your calculator, at least for integer values. So if you have a graphing calculator, I'm going to just pull up the graphing calculator here. Again, I apologize for the ads. Just make it doesn't seem like window wants to make it go away. So to get binomial coefficients on your calculator, you go to the math button, probability option, number 3 there, 4 there on mine, and then NCR is the option. Now for my calculator, I have to type the first number in. So for example, 12, and then NCR button, 6. And then it spits out the answer. Now again, I don't know if my calculator is going to obey some of the other rules. I'm just going to do 5 NCR. Apparently I have to type the NCR part first. It doesn't take the first number. Again, okay, my calculator happily gives me 0. So he is doing what he's supposed to do. Okay. So that's how it works on your calculator. Again, I don't know if he's going to work with some of the other stuff we're going to do later. Let's just try one real quick. Let me try 1.5 NCR4. Okay, yeah. My calculator will not do the things we're going to do later. Later on, we're going to talk about doing these with a fraction or decimal, but our calculators won't be able to handle that. Okay, so thought that might have been a limitation they were going to have, and it turns out that is the case. Okay, so that is the binomial coefficient. We're going to see a little bit of what it means in a moment. We'll talk a little bit about what it means and how to use it here in some upcoming examples. binomials. But first, we just wanted to talk about how to compute it.